Hi, welcome back. Today I'm gonna walk you through the electronics of the sticky watch.
Alright, let's get right into it. So here's the whole thing taken out of the case. Here it's the empty case. This thing is powered by a LiPo, lithium polymer battery. And yep, here's the speaker, microphone, buttons, and Surface Mount LEDs are up here. And on the flip side, I have the ISD1700 chip, which I'll come to later. And the whole board just stacks on top of this Microduino microcontroller board. It's an Arduino compatible board and it's tiny like this, so that's good. Yep, about the ISD1700, this is where the magic happens because it's got everything built in. It has an ADC, DAC, flash memory, a microphone preamp, and the best thing is that I can talk to it via a SPI interface. It's not that I'm gonna spy on you with this little watch, obviously. SPI stands for Serial Peripheral Interface or something like that. And yeah, it's a protocol to communicate with a microcontroller. And yeah, that's that. So here's the schematic diagram for the board. It's got the ISD1700 chip in the middle, and yeah, there's an excellent design guide provided by the manufacturer of this chip online, so I'll link it down below. And yeah, the circuitry is basically copied from that document. All these caps and these bias circuits. Yeah, the ISD1700 chip talks to the Microduino via these 4 lines using an SPI interface. And here's a transistor that turns on the microphone biasing circuit whenever needed, because without it it's gonna be like 14 kilo ohms across the power line and the ground, and it's gonna suck like 2 milliamps on idle, and that's not good. So I added that. And yeah, these LEDs and these switches are controlled by the Microduino, and yeah, that's pretty much it. Here's the board layout. This board is a little bit different in layout to the one I showed. This one is currently under manufacturing in Shenzhen, and yeah, it was pretty tough to get all this together. I'm using Eagle, by the way. There's not much to talk about this, but in the end I think I did a pretty good job on this. And here's the code that runs on the Microduino. I'm not gonna walk you through every step of the programming, it's gonna be boring otherwise. And yeah, all the schematic, board layout, and the code is gonna be on GitHub by the time this video gets out. So here's something I want to show you, and it's right down here. So this function takes care of monitoring the battery voltage, because LiPo has this property that if the voltage on it drops below 2.7 volts, it's gonna die. Yeah, so I have to constantly monitor the voltage of the battery and shut down the whole thing when the voltage gets too low. And it's gonna require some hardware to do this usually, but there's a neat trick to do this without any added hardware. So yeah, I'll link to that down below. And this code has some power management features built in, because it's a watch, you don't want to recharge it every night like you have to do with an Apple Watch or something like some other smartwatches. Watches usually have like crazy battery life, like 10 years even. I'm not aiming for 10 years, of course. I'm just aiming for a month or so. So yeah, my solution was to go to sleep every time it finishes an action. So here's the code for that, ABR sleep. There's some excellent articles online, so I'll link to that down below. And that's about it for the code. Thanks for watching, guys. Next time we're gonna bake some PCBs in an oven. Stay tuned.